All right, guys, today we're going to talk about the shell method and learning about the shell method, even though it is not required on the AP exam. As you're going to see today, it makes finding the volume of solids that are revolved around a vertical line, such as the y-axis or the line x equals 2 or the line x equals 8, a lot easier than using the washer method. What we're going to see is that one of the values of the shell method is that it actually enables you to always be able to integrate with respect to the letter x because the representative rectangle that you draw for the shell method is going to be parallel to the axis that you're rotating it around. So let's see if we can sketch, let's just say, we're not even going to use any particular, well, tell you what, we are going to, why don't we say we'll use the curve y equals x squared. All right, so y equals x squared to illustrate this. And the line, let's say x equals 2. And we want to revolve this region around the y-axis. So here is our region. And we want to revolve that around the y-axis. Okay, so up to this point we have been using for this particular problem we would have to use the washer method. But instead, now we're going to learn something called the disk method, or excuse me, the shell method. And the shell method, we're going to draw a rectangle that this time is parallel to the axis you're rotating it around. And you can see that when you rotate this rectangle around, it's going to form a shape that looks something like that. All right, like a cylinder, but a hollowed out cylinder. We'll call it a shell with a little bit of thickness. So I'll see if I can do my best job at drawing this. So we see here it's going to, I am not a good artist, but I will do my best here to help you visualize what this is going to look like. All right, and so, all right, and right there. Okay, so basically when you rotate this around, it is going to form some sort of, like I said, a cylindrical shell with a thickness, with a big opening in there. And as you can see from the drawing, you're going to be taking an infinite number of these rectangles in this region and just wrapping them around the y-axis, and it's going to form a solid. Okay, now, so our goal is to find the volume of this particular resulting solid. Now, as you look at it, you may think, well, that looks kind of weird as far as how to find the volume of that. However, if you take this, tell you what, let's say we take this, just this red shell, and flatten it out. All right, so think of it like you're basically flattening it out. Well, if you flatten it out, it's going to form something that looks like this. Okay, once again, this is not a great drawing, but I think you'll get the point. If you flatten it out, it's going to form a prism, right, or just a rectangular prism. So, if you flatten this out, then the length of this prism is simply going to be the circumference of the shell that you had at one point. It's going to be the circumference of that, all right, because you're basically flattening it out. So the length of this prism is going to be the circumference, okay? And then the height of the prism, all right, is simply going to be, we'll just call that h, and then dx we will call the thickness of it. All right, so if we call this point on the curve xy, all right, then the volume of that one cylindrical shell is going to be 2 pi, and the radius is simply going to be the letter x, and the height of this shell is going to be the letter y. But y is defined as x squared, and the thickness of this shell is dx, and that is going to give us the volume of one of these cylindrical shells. And we would want to integrate this from 0 to 2 pi x times x squared. Now keep in mind what this is. This is the radius. This is the height, so we'll put that in quotes. This is the height. And this is your thickness, dx. All right? So you can take the 2 pi out front, and you get 2 pi integral from 0 to 2 of x cubed dx. And that's just simply going to be x to the 4th over 4, and 2 to 0 with a 2 pi out front. Plug in 2, you get 16 over 4, which is 4 times 2 pi is going to be 8 pi. And you plug in 0, obviously you don't get anything. So 8 pi would be the volume of this region wrapped around the y-axis using the shell method. All right, in example 1, we are going to see right off the bat here the value of using the shell method and why it is useful in order to learn this method. Now, let me just say from the beginning, the shell method is not required on the AP exam. However, you're going to see today it is very helpful to understand how to use this method. Once again, let's highlight a few things. The shell method, the r of x is the distance from the axis of rotation to the center of the representative rectangle. All right, h of x is the height of the rectangle, and basically that's all you need to know. All right, a and b are the lower and upper limits of the region that you are rotating. All right, so also I want you to note this. It is usually easiest to work with disks when you're rotating around a horizontal axis, and shells when you're rotating around a vertical axis. That way you are always integrating with respect to the letter x. All right? So, example 1, we're going to do it in 2 different ways. We're going to first do it with the disk method, and then we're going to do it with the shell method. We're going to get the same answer, and then we're going to answer the question, which method is more preferable to use in this example and why. All right, so example 1, we've got y equals x squared plus 1. So why don't we go ahead and draw that. That is just a parabola that is shifted up 1 unit. And then y equals 0 is just the x-axis. X equals 0 is the y-axis. And x equals 1 is just the vertical line, x equals 1. So we will draw that in there. And so we know that this parabola is going to be connected at 0, 1. And if we plug 1 into the parabola, we get the point 1, 2. So we have this parabola right there. And we want to take this region and we want to rotate it about the y-axis. Okay, now we run into a problem. All right, we run into a problem because notice that this is one of those problems that if we're going to rotate it around this axis, then we're going to have to create 2 different regions. All right, we're going to have to create we'll call this region 1, and we'll call this region 2. And you're saying, Mr. Parr, why do you got to create 2 different regions? Well, let's think about it. If we put our representative rectangle right here, and we're trying to rotate it around the y-axis using the disk, using the washer method, then you can see that this representative rectangle is not going to work for region 1. Region 1's rectangle is going to look like this. All right? And so we have to break this up into 2 different regions. All right, so let's first work with the easier region, region 1. All right, so region 1, if we imagine region 1 as being simply a rectangle, All right, of one big rectangle. So let me just outline that. One big rectangle. All right, now if you take that rectangle and you rotate it around the y-axis, let me just draw what it's going to look like here. It's going to form a cylinder, a basic geometrical cylinder. So we already know the volume of a cylinder is going to be pi r squared h. All right, so what is the radius? The radius is 1. All right, because the radius is this distance, and that's just 1. And what is the height? Well, the height is this distance, and that's also 1. So, hey, we already have the volume of region 1. It is just pi. So we've got that. All right, now let's work on region 2. Region 2, we are going to have to use the washer method. And what is the washer method again? Well, the washer method is pi, the integral. And now notice this is a dy strip, so we need to be integrating according to the variable y. So we're going to integrate from when y is 1 up to when y is 2. And then capital R, don't forget, is the distance from the axis you're rotating to the furthest part of the rectangle, so that's capital R. And then little r is the distance from the axis you're rotating to the closest part of the rectangle. And we're going to call this point right here x, y. All right, so what is capital R? Capital R is just 1. So that's going to be 1 squared. And what is little r? Well, little r is going to be simply x. So r is equal to x. All right, the distance from the axis you're rotating to the closest part of the rectangle, which is just x. So we need to solve this equation for x. So that is going to be, let's say, y equals x squared plus 1. Y minus 1 equals x squared. And once again, what are we going to do with little r? We're going to square little r, right? So little r squared is really x squared. So we really don't need to solve this for x because we're going to square it anyway. So that's just going to be y minus 1 dy. And so then now we have, if we clean this up a little bit, we distribute this negative sign in here, and we end up getting 1 minus y plus 1, so 2 minus y from 1 to 2 with a pi out front, dy. And then we integrate 2 and we get 2y. Integrate y, we get y squared over 2. And now we're going to plug in our upper and lower limit. So you plug in your 2, you get 4 minus 2, which is just 2, minus, now plug in your lower limit, you get 2 minus 1/2. So what do you get? You get 2 minus 1.5. 2 minus 1.5 is 0.5, all right, 0.5, or let's just say 1/2, actually. But don't forget, we have a pi out front of our integral, so it's pi over 2. And remember, that is the volume of region 2. Don't forget to add that to the volume of region 1. So you have pi plus pi over 2, which gives you a volume of 3 pi over 2. All right? Now, I don't know about you, but that was complicated. That was complex. So we're going to do the exact same problem using the shell method. And you're going to say, whoa, that is a lot easier. All right, so we're going to draw the same curve. We're going to draw the same parabola. So this is going to be x squared plus 1. We've got the line x equals 1. And we want to take this region, and let's just shade the region. We want to take this region and we want to rotate it around the y-axis. Well, we're going to now use the shell method. All right, and so the shell method, we need to draw a rectangle that is parallel to the axis that we are rotating it around. And so using the shell method, all we need is two things, r and h. R is that distance right there. Okay, that is little r. And h is the height of the rectangle. So that's h. All right, so if we call this point, once again, x, y, same thing we've been doing, then what is r? Oh, little r is x. And what does the shell method say? It says 2 pi. The integral from, well, what's the region we're rotating for? Well, it's going to be from 0 to 1. And then little r is going to be x. And the height of this is going to be y. But y is defined as x squared plus 1. And the thickness of this rectangle is dx. Alright, so what do we have? We have x cubed plus x. And then we're going to integrate that. So that's going to be x to the 4th over 4 plus x squared over 2. And we're going to plug in 1. And I'm going to continue this up here. We plug in 1, we get 1/4 plus 1/2. And so 1/4 plus 2/4 is 3/4. But don't forget, we've got a 2 pi out front. So that's going to be 6 pi over 4, which reduces to 3 pi over 2. And we are done with this problem using the shell method. That took 2 or 3 steps. We didn't have to break it up into 2 different regions. That was a lot better. All right, example 2, it says set up an integral, but we don't have to actually evaluate it. We just need to set it up. That can be used to find the volume when the region bounded by y equals square root of x, y equals 0, and x equals 4 is rotated about the given axis using shells. All right, so let's see if we can set this up. First of all, we need to be able to graph it. So the square root of x looks something like that. And the line x equals 4 is going to be just a vertical line. So this is 4, this is 0. We don't really need this point, but this would be the point 4, 2, because the square root of 4 is 2. And the y equals 0 is just the x-axis. So the region that we are trying to rotate, all right, is this region right here. And the first thing it says that we need to do is we need to rotate it around the line x equals 7. Oh wow, that is way out here. So probably need to use a different color for that. Let's use blue. All right, so x equals 7 is out here. So we need to take this region right here and we need to rotate it around that vertical line. All right, so once again, we are rotating around a vertical line, so it is best in this case to use the shell method. So we're going to set up a rectangle, and let's keep in mind what the letters represent for the shell method. The r is the distance from the axis that you're rotating to the rectangle. So this is little r. And h is the height of your rectangle. So once again, we're going to call that point x, y. And so what is little r? Well, it's going to be 7 minus x. 7 is the entire distance that I'm outlining right there. X is simply this distance. So to get this distance that I'm just messing around, that is going to be 7 minus x. Okay? So little r is 7 minus x. So we have 2 pi, the integral from 0 to 4, because that's the region that we are rotating. And little r is going to be 7 minus x. And then the height of our rectangle is represented by the letter y. But y is defined as the square root of x. So the square root of x, and we are done. All right? That is part A. Part B, we want to take the same region and rotate it around the line y equals 5. So let's set this thing up again. All right, we have the x and y axis, we have the curve square root of x, and we have the line, well in this case we have x equals 4, and now we want to rotate this around, so let's just highlight our region here. This is our region, and we want to rotate this guy around the line y equals 5, which is up there somewhere. All right, and we want to use the shell method. All right, now if we had our choice here, I would probably use the washer, but they want us to use the shell. So we need to set up a rectangle that is parallel to the axis that you are rotating it. So it needs to be a horizontal or a dy strip. And so once again, what is the radius? The radius is the distance from the axis that you're rotating around to the rectangle. Well, if we call this point right here xy, we're going to keep doing that, then the radius is simply going to be 5 minus y. Once again, 5 is this entire distance, and y is this distance. So if you want to get this distance, you got to subtract them. So 5 minus y is your r. So let's just say r of y is 5 minus y. Okay? So far our integral should look like, well, now where are we integrating? Well, earlier I said that point was going to come in handy. We need it here. 4, 2. So now we're integrating up and down the y-axis. So it's going to be from 0 to 2 pi. And the radius is 5 minus y. And the height of our rectangle is essentially going to be that distance right there. And so the height of the rectangle is simply going to be 4 minus x. 4 minus x. All right, but we can't do anything in terms of x, so we've got to solve this equation, y equals the square root of x. We've got to solve that for x, so we're going to square both sides. Y squared equals x. All right, so this is going to be 4 minus y squared, and that is your height, and dy is the thickness of our rectangle. And this problem says just set up the integrals. We don't have to solve them. All right, example 3 is, I wouldn't say it's complicated, but it's a little bit more involved than the other ones. It says find the volume of the solid generated by revolving the region between y equals x squared and y equals x to the 1/3, which is just the cube root of x, about the y-axis. Use both methods. All right, so we're going to start by graphing this, and let's just start with the parabola, x squared. That is going to be just a simple parabola. And then we have the cube root function, which is going to look like that. And we could find the intersection, but you can also just kind of look at it and see that when x is 0 for both of them, they both go through the origin, so that's going to be one intersection. And then when x is 1, 1 squared is 1, and the cube root of 1 is also 1. So they're going to intersect at the point 1, 1. All right, so let's put that in there. And so our region that we are trying to rotate is this region right there. Okay, so we need to first do it by shells, rotating around the y-axis. So therefore, we need to draw a rectangle that is parallel to the axis that we are rotating. All right, so we're going to call this point x1, y1. And then we're going to call this point up here x2, y2. And really, x1 and y1 are the same distance from the x-axis or from the y-axis, so we really don't need x1 and y1. X1 and x2, excuse me, but y1 and y2 is clearly different heights, so that's what we need. So now we're going to use our shell method, and we're going to integrate. So it's going to be 2 pi. We're going to integrate from 0 to 1, and then, well, what is our radius? Remember, our radius is the distance from the axis you're rotating to the rectangle. Well, that's just going to be x. All right? And then the height of the rectangle is going to be upper curve minus lower curve. So that's going to be your x to the 1/3 minus x squared. And then the thickness of this rectangle is dx. All right? So now we're going to distribute, and we get x to the 4/3 minus x cubed. And now we're going to integrate. And so after we integrate, we're going to get 3/7 x to the 7/3 and minus x to the 4th over 4. And integrating from 0 to 1. Hey, I like this because plugging in 1 simply just gets you 3/7 minus 1/4. So 3/7 minus 1/4. And plugging in 0 just gives you 0. So now we just need to get a common denominator, which looks like it's 28. And so let's just see, do a little simple math here. We'll multiply this one by 4, multiply this one by 7. And so what do we get? 12 over 28 minus 7 over 28 equals 5 over 28. But don't forget to multiply by 2 pi. So 2 pi times 5 over 28 gives us 10 pi over 28, or 5 pi over 14. And that is the answer using the shell method. Now we're going to do the same thing using the disk method. All right, and we're just doing these so you can see that there's different ways of doing these, but you can choose which one you think is better. All right, so once again, we've got the parabola, and then we also have the cube root curve, and they intersect at 1, 1. And the region that we're rotating is this region right here. And we're rotating around the y-axis, and we're going to use it says discs, but they really mean washer. And so we're going to use the washer method. So we're going to draw a rectangle that is perpendicular to the axis that we're rotating it around. And we're going to call this point x1y, and I'm just going to call it x1y. We'll call this point x2 and y. And once again, y is the same height for both points, so I'm just calling it y. But the x's are different, all right? And so for the washer method, the capital R, it's going to be, let's remember, it's going to be pi, the integral from a to b, of capital R squared minus little r squared. And so capital R is the distance from, so let's just see if we can draw this, the distance from the axis all the way to the furthest part of the rectangle. So that is just simply going to be x1. So x1. Now x1, we're going to have to solve the parabola for y, because this is a dy strip. So the parabola is y equals x squared. So x equals the square root of y. All right, and so if we square that, because we have to square capital R, that's just going to give us y. All right, so we have pi, the integral from, once again, 0 to 1, but not along the x-axis this time, 0 to 1 along the y, and capital R squared is just going to be y. All right, and then little r is going to be the distance from the axis to the closest part of the rectangle, and that is going to be the other functions, the red function in terms of y. So if we solve this one, let's say y equals x to the 1/3. Well, we're going to cube both sides. So y cubed equals x. All right, and that is little r. So if you square little r, you're going to get y to the 6th. And then you have dy. All right, so now we're going to integrate, and you get y squared over 2 minus y7 over 7. And then you're going to plug in 1, and you get 1/2 minus 1/7. And we can get a common denominator of 14. So this is going to be 7 over 14 minus 2 over 14, which is 5 over 14, times the pi out front gives us 5 pi over 14, which is the same answer that we got using the shell method. All right, for the granddaddy of them all, example 4, and now we're going to see the value of the shell method, and we're going to see that there are some instances where you have to use the shell method in order to find the volume, and this is one example. All right, so it says find the volume of the solid formed by revolving the region bounded by the graphs x cubed plus x plus 1, y equals 1, and x equals 1, and about the line x equals 2. All right, so let's graph this guy first. And let's say you don't even know what the shape of this graph looks like. Hey, no worries. You can always plug in points, right? So we know y equals 1. That's just going to be this line. And we know x equals 1. That's just going to be this line. All right, and so we can actually plug in, and we're wrapping it around some other line. So this is really complicated. We're going to wrap it around some other line, x equals 2. So this is the x equals 2 line, and this is the x equals 1 line, and this is y equals 1 right here. Well, we know it's a cubing function, and so if we plug in 0, we will get 1. So this point is the point 0, 1. And if we plug in 1, it looks like we will get 3. And so that is going to be the point up here, 1, 3. Okay? And we know it's a cubing function, so it's going to look something like that. All right? And so what is the region that we are interested in rotating? It's going to be this region right here. All right? And we're interested in rotating that region around the line x equals 2. All right, so for this, let's just say, for argument's sake, that you want to use the washer method. Well, if you use the washer method, you're going to have to draw a rectangle that is perpendicular to the line x equals 2, and you're going to have to solve this equation right here for x. Well, you can't solve it for x. You're stuck. You cannot solve that equation for x. You can't isolate x, so you cannot use the washer method. So here's where the beauty of the shell method comes in. And so we're going to take a rectangle, and we're going to make it parallel to the line x equals 2. And we're going to call this point, once again, x, y. And so what is the radius? The radius, once again, using the shell method, is the distance from the axis to the rectangle. So this is going to be little r right there. And that's going to be 2 minus x again. So we're going to have the integral from 0 to 1. 2 pi is out front for the shell method, and little r is going to be 2 minus x. And the height, is this going to be upper curve minus lower curve? Well, the upper curve is your parabola, your cubing function, which is going to be x cubed plus x plus 1. And the lower curve is simply the line y equals 1. So, and then the thickness of the rectangle is dx. Well, these two guys cancel out, and you can go through the process and integrate that by hand, and you will end up getting 29 pi over 15. And that is the answer to example 4.